Okay, welcome back. So for part 1, we have revised how to draw a straight line. Just 2 dots, and then the general equation is y equals to mx plus c. M is a gradient, c is a y-intercept. For part 2, we have learned how to draw a curve, quadratic curve. And then to find the x-intercept, you can find the solution for the quadratic equation. Okay, so now we are going to learn something more advanced. Okay, after drawing this graph, how many quadratic equations have we solved? Okay, during the last session, we know that by finding the two x-intercepts, we can solve this quadratic equation of x equal to 0 equals to x squared plus 2x minus 3. Okay, minus 3. Okay, can we solve other quadratic equations using the same graph? Because if we are going to draw every single time we are going to draw a new graph to solve a new quadratic equation, it will be too troublesome. Okay, so how can we use the same graph to solve different quadratic equations? Let's start with a simple one first. For example, if we want to solve negative 2 equals to x squared plus 2x minus 3. Okay, for say, if this time we are going to solve this quadratic equation. It means what? The right hand side, x squared plus 2x minus 3, is exactly the same. So the right hand side is a curve. Okay. Then for the left hand side, it goes to negative 2. It means what? We are supposed to find a point, or probably one point, okay, which gives you a y value equals to negative 2. So over here, it means what? Let me highlight this line. Okay, this straight line is what? Is when y equals to negative 2. Okay, because this line is parallel to my x-axis, and then over here you can read the y coordinate 2, 2, 2, 2, 2. So here is negative 3, negative 2, negative 2, negative 2, negative 1, negative 2, 0, negative 2. So any point on this straight line, okay, parallel to x-axis, will have the same y rating as y equals to negative 2. So the line equation for this straight line is y equals to negative 2. So you see, what happens for these 2 points? The intersection point of the y equals negative 2, the red color straight line, and the curve, and our curve. Can I say that the right color straight line is representing the left hand side of this new equation, and the right hand side is the curve? When the left hand side equals to the right hand side, it means the intersection point. The intersection point. Okay? So by reading the x coordinates, okay, we can solve the solution, 2 solutions for this new equation. Okay, so this is how to use the same graph to solve a different quadratic equation. Obviously, after knowing this method, we can solve more quadratic equations. For example, if you want to solve, it's no longer negative 2. If you want to solve negative 3 equals to x squared plus 2x minus 3. Okay, then how is it supposed to solve? We draw a straight line parallel to x-axis over here. So for this point, negative 2, negative 3, and this point, 0, negative 3. Okay, these are the 2 intersection points. It means what? It means the 2 solutions for this new quadratic equation over here will be 0 and negative 2. Okay, and then obviously I can has some new values, for example, -4. If I have -4 equals to x squared plus 2x minus 3, then we are going to apply the same method. But as you can see this time, it's no longer 2 points. It's no longer 2 intersection points, but only 1 when x equals to -1. Okay, so for quadratic equation, if you have any line over here, you have 2 solutions, this one and this one. If you have just the line over here, you have 1 solution. If you have any value over here, any y value smaller than -4, for example, this line, you will have no solution at all. So there will be 3 possible cases for quadratic equation. 2 solutions, 1 solution, and no solution at all. Okay? So over here, these are the simple ones. Okay, let's start with a slightly difficult one, because over here we are only drawing straight lines parallel. Okay, let's try one more. Okay, for example, if this time I want to solve x squared plus 3x minus 3 equal to 0. If this time that's, okay, let's change it again. Change it to x. Okay. If this time this is the new quadratic equation I'm going to solve, x squared plus x minus 3 equal to 0. Can I solve using this graph we have already drawn, which is x squared plus 2x minus 3? Okay, yes, you can. Just remember, the method is finding a straight line and then to have intersection points with the curve we have already drawn. Then we can solve the 2 solutions. So it means what? We must have left-hand side as our curve, or you can use right-hand side as well. We must have one side, okay, of the equation. Let me draw the equal sign. We must have one side, for example here, right-hand side, as our original curve. So you will fill in over here. Okay, the other side, we will have a straight line. Do you remember the general equation for straight line? Mx plus c. Okay, so it means what? It means we are going to transform this equation, or the equation we call the equation 1. We are going to transform this equation 1 into this second line format, so that it's a curve and a straight line. But this time, it's no longer a straight line parallel to x-axis. It will be a slanted straight line. And then we are going to find the 2 intersection points of this straight line and this curve. So similar concept. Okay. So how are we going to transform equation A to the second line? We write down the second line first, and then we simplify by bringing over every single term to the right-hand side. Okay, so we have 0 equals to x squared plus 2x minus 3. Remember, bringing over plus and minus, you need to change sign. So minus mx minus c. Okay, after that, regroup all the x terms and all the common terms. So we have x squared plus bracket 2 minus m x minus bracket 3 plus c. Okay, so I'm regrouping these 2 x terms and these 2 constant terms, and I take out the common factor of x, so that I have a coefficient of 2 minus m. And over here, I add a bracket for the last term, which is 3 plus c. Over here is minus 3 minus c. You have a minus in front, so you add a bracket, you need to change sign over here. Okay? So after getting this form, we are going to do a comparison. Compare with which one? Compare with the first equation. Okay? We must have the coefficient for each term to be the same. So for x squared, do they share the same coefficient? Yes. Okay? For the second term, x, they must have the same coefficient. It means what? It means 2 minus m equals to 1. For the last term, -3, it must be the same thing. So it means 3 plus c equals to 3. That's why over here can be a -3, over here can be a 1. It means solve this equation, linear equation, simple equation. So we get m equals to 1. 2 minus 1 equals to 1. Over here, you can solve as c equals to 0. Okay, because 3 plus 0 equals to 3. So m equals to 1, c equals to 0. Now is the time to rewrite this part, because we have already solved the m and my c, which is x plus 0. So I just ignore the 0. Okay? So after this conversion, what do we have? The curve and this y equals x. Okay? So it's y equals to this curve and y equals to x. You have this curve and this straight line. So we are supposed to find the two intersection points of this straight line. How to draw a straight line of y equal to x? Yes, you create a table, x and y. And then remember, during the first session, we learned what? For straight line, you don't need to draw 5, 6 points. Just 2 pairs. Okay? For example, do 0. So start in x equal to 0, your y equal to 0. Start in x equal to 1, your y equals to 1. So over here, on the graph, we are going to draw 2 dots of 0, 0, and 1, 1. Okay? After that, we are going to draw a straight line linking up these two. And then yes, we are going to extend this side as well. Okay? Make sure you use a ruler and then draw a straight line for this one. Okay, after that, you see this intersection, these 2 points. Okay, let me clean up this part a bit to show a clear graph. Okay, these 2 points. So you read the x value. So you have one x, you have a second x. You read the x coordinate. It will be the two solutions for this original equation, x squared plus x minus 3. Okay, so by using this curve and the straight line can either be parallel to x-axis or just any new straight line, slanted straight line. It can pass through the origin of 0, 0. It can just go anywhere else as well, depending on how you transform and how you calculate m and c. Okay, so this is how to use a graphical method to solve quadratic equations. Okay, and that's the end of this session.